Okay, let's keep working with some derivatives here. Now we're moving on to the product and the quotient rules. So we have two different rules that we're working with today. So up to this point, we haven't learned how to take a derivative when things are multiplied or divided. But guess what? Today is the day. So we have the product rule. And here it is. If f and g are differentiable at x, then the derivative with respect to x of f of x times g of x is equal to f prime of x times g of x plus f of x times g prime of x. That's the rule. All right, here's what you say in your head. If you have two functions that are multiplied together, this is what you're actually doing. You're going to say the derivative of the first times the second plus, I'm going to write the word plus because we're writing everything else out. The first times the derivative of the second. Derivative of the second. Okay, so that's what we're looking at. So when you have two things that are multiplied together, the very first thing you see, you take a derivative first, then the second one comes along for the ride. It's multiplication, so we know plus is its buddy. Then, once you take the derivative of the first term, then you do the other one. Then it comes along for the ride, and you take the derivative of the second. So of these two terms, the first term is the first derivative. The second term, you take the second derivative. Not too bad, right? Derivative of the first times the second plus the first times the derivative of the second. We got this. Let's do some examples. So here's example 1. We're going to find the derivative. And we have h of v is equal to v squared times 2 square roots of v plus 1. Now, let's go purple on this. Here's a note, and here's a big note. All right? In reality, you would, that's an LD, would do algebra first, then take a derivative. But we are going to practice the product rule on these wimpy problems first, so you learn it. You guys know I'm all about efficient math, right? So I want to be very clear. In reality, there is no way you would do the product rule on this. You would distribute this, do the power rule, and call it good. However, we are learning the process of the product rule. So we're going to learn the process on these wimpy little problems that we're looking at so that we can practice that process. All right? Yes, this is quote unquote a formula. You can't see me air quoting, but I am. But it's really not a formula. It's a process. So if you understand the derivative of the first times the second plus the first times the derivative of the second, that's the process. The product rule, the quotient rule, this is all a process that you can apply to anything. All right? So with that in mind, this is going to be f of x, and this is going to be g of x. Those are my two functions that I'm multiplying together. And what do we know? As soon as you see a radical, what do you automatically do? Change it to an exponent. Good. H of v, I haven't taken any derivative yet. V squared times 2v to the 1/2 plus 1. Don't go changing that to an x. you need to get used to working with variables other than x. So if there's a v in the problem, leave that v. If there's a t, if there's a whatever, leave that variable. All right? Now, h prime of x, the derivative of the first, so the derivative of 2v, pardon me, of v squared is 2v times the second, I'm not touching that one, plus the first times the derivative of the second. So I'm going to bring this 1/2 in front, take it times 2, and then I subtract 1 from that, and that's how we get the negative 1/2. And then 1 is a constant, so then I don't worry about that. Now this 2 cancels out that 2, right? And here I have like bases. When you multiply like bases, you add the exponents, right? Same thing is happening over here. When you multiply like bases, you add those exponents. Oh, I said all that stuff about v, and you guys are probably hollering at me, but you put an x. You're right, I did. That's on me. Fix it. So now I have 4. This is the same thing as v to the first, so I add those exponents. 1 plus 1/2 is 3/2 plus 2v plus, and here 2 plus a negative 1/2 is 3/2, right? So now I have like terms. So h prime of v is 5v to the 3/2 plus 2v. Calculus is easy, right? The algebra is what gets ya. So pay attention to that algebra, right? The calculus is just this process. Bam, get this process down, and then you can move on. So derivative of the first, when you see two things that are multiplied, the derivative of the first times the second plus the first times the derivative of the second. All right? Okay. Let's do one more here. Here is example 1b. Find the derivative again. Of course, that's what we're living right now. And I have f of x is equal to x cubed minus 8 and x squared plus 4. If we were in reality, right? If you're just doing this because this problem shows up, we're not learning a process where this problem just showed up, what would you do? Yes, you'd FOIL that out. You'd algebra it first. However, let's practice. So this is our practice. F of x and g of x here. Okay, so f prime is going to be the derivative of the first. So we've got 3x squared, right? Bring the exponent in front and subtract 1. That's a constant. Times the second, because I don't touch it. Plus the first, not touching it, times the derivative of the second. So I've got this x squared, that's a constant. So the 2 comes in front, and I have a 2x. All right? Now you algebra. Distribute, and clean it up. F prime of x is now equal to 3x to the 4th plus a 12x squared plus a 2x to the 4th minus a 16x. Combine those like terms. So f prime of x is now equal to a 5x to the 4th plus a 12x squared minus 16x. You can factor out an x if you want to, or leave it in. It doesn't really matter. All right? All right. Product rule. Good stuff.